Okay, Bruins, here's our 2-minute recap of what happened in science today. We started by looking back at these words: inertia, momentum, and impulse. Inertia is the resistance of an object to move or change its motion or direction. Momentum is the relationship between mass and speed. And impulse is a force applied for a period of time. We saw this principle of impulse in action in the egg toss video when 2 eggs were thrown with the same speed and had the same momentum and came to a stop. 1 egg smashed and the other didn't. Okay? So we wrote these 2 questions on page 76 of our interactive notebook. What is the key to bringing a person's speed to 0 safely? And what is change in speed over a period of time called? For question number 1, the key to bringing a person's speed to 0 safely is to increase the time of impact. So we want to make the time bigger and then decrease the force during the impulse. So think of it as the difference between slamming on the brakes in your car and then slowing to a stop at a stop sign. Question number 2, what is the change in speed over a period of time called? We call that acceleration. So acceleration can be positive or it can be negative. And when it's negative acceleration, we also call it deceleration. We skipped these 2. We started our bean brain project. Okay, so you're going to be working in your groups to engineer protection for a bean brain that will allow it to survive a hazardous event, a fall from the ceiling to the floor in a protective capsule. This is going to represent a major collision in which a human is protected by a helmet. So we wrote down these 2 definitions. Criteria, this is also on page 76, are standards or instructions. Constraints are limits. And I'm going to go fast. You can feel free to pause at any time to catch up on your writing. Their egg holder will need to meet the criterion of protecting the egg from cracking or opening upon impact. So we're going to have the criteria of designing a protective device that prevents the bean brain from spilling out when dropped from a certain height. It's going to be from the top of a ladder. The device must fit around the bean brain. It should be as compact as possible, minimizing material costs and space. One of the we talked really quickly about these, don't worry about those. Constraints. You're going to use materials that you bring from home. So I will not be supplying any materials. These materials can be wrapped around the bean brain, but they can't exceed 20 centimeters in any dimension, and they should not be attached in a manner intended to hold the bean brain shut. So you can't actually hold anything closed. So here's an example of our bean brain. You can't just use bubble wrap and tape. That's not going to be a sufficient device. You need to design a device that's like a helmet that you can place the bean brain in and remove it, but you can seal it shut. Okay. And we have page 77, which is our helmet design plan. You'll need to get one of these in class. You're going to design it, explain it, and provide a list of materials. This is what we did today in class. Tomorrow is actually going to be our building day. You may want to bring in some supplies with you if you're going to be coming to class tomorrow. If not, hopefully we'll see you by Friday when we drop those bean brains. Have a lovely day.